Okay, today is 7.2 review. This is, if you were following along, I've been doing a couple chapters each day. Today is such a big one, it's chapter 4, that we'll only get through one chapter today. And I'll get through 2 or 3 tomorrow. That'll go quicker. But quadratics was huge. We spent a month on quadratics. Okay, so to spend a day reviewing it is as it is, going pretty fast. All right, so this one, 7.2 review worksheet, has a problem at the beginning. I'm going to start with you. Whenever I do a problem, what I decided is that is part of your assignment, so you should do it with me. So they're going to do number 1 together. And I'm going to leave you only selected problems this time. You know, last time I said do every other do the even problems in even letters. So this time I'm going to only pick, do this one, do that one, do that one. I'll show you which ones I want you to do. Okay, number 1. I do need you to do this one. A lot of people have forgotten that these are the factors that give us the x-intercepts. So it's 4 and 0. So what does this mean? That there's a 4 here. That's not where 4 is, sorry. The numbers are all messed up on this. 1, 2, 3, 4 is right there, and 0 right there. Do you get that there's a parabola going through those? Okay. So what they ask you is a whole bunch of questions like, if I just kind of loosely draw this through here, I'm not sure exactly where the vertex is. Could you figure out exactly where the vertex is? Sure you could. That was one of your assignments. That's one of the things we did. Do you remember that it is for sure on this line? That's the line what? Line of symmetry, true. And it's a line at what in this case? X equals, no. X equals 2. This is x equals 2. Axis of symmetry has an x in the word axis, and it has an x in the equation. Axis of symmetry has x equals 2. What does that mean? That means that somewhere, whether it's here, or here, or here, or here, or here, one of those spots is the vertex. You can just kind of guess and check your way to doing this, because you know that from that vertex, you're going to go over 1 and up 1 and over 2 and up 4. But there's a smarter way. Who remembers the smarter way to use x equal 2 to find the vertex? Yes, Miss F. Yes, put the 2 in there. So it's 2 minus 4 and 2 plus 0. Good. What is 2 minus 4? Negative 2. Times, what is 2 plus 0? 2. So it's 2 times negative 2 times 2. Negative 4. All right. I'm doing this problem. This is number 1, and we're signing it together. So this is negative 4. And what did we just find? Y is negative 4 of the vertex. Good. And the x was 2. So therefore, the vertex must be at 2, what? 2 comma negative 4. All right. Just looking at it, I should hope that you could tell if that's a low spot or a high spot on the parabola. And therefore, is it a min or a max? All right, good. Moving on, the equation in general form. Generally, you just need to multiply it out. So go ahead. You know how to FOIL things out. FOIL that thing out, and you'll know the general form for it. And then finish this sentence. The y-intercept is where x equals 0. Stick in 0 for x. You'll be able to solve it, and you'll know the y-intercept. That's an easy one. Okay, your assignment is number 1 that I just helped you with, and number 2 on this page. Okay, for number 2, it's a little different because it's in vertex form. I hope that the vertex is kind of stands out to you. I'll pause for a second while you give this number 2 a shot. Okay, back to the recording again on number 2. We're going to find the vertex. Well, it's just sitting right there. Did you remember that it was negative 6, comma, negative 1? A lot of times people forget that and think it's positive 6, but the stuff on the inside you can't trust. Another way to say it is when you stick in a negative 6 in the equation, that's how you get the negative 1 to come out. The negative 6 here, that all cancels, and it turns into y equals negative 1. Okay, so anyway, negative 6 comma negative 1. Where is that on the graph? Negative 6, negative 1 is about right there. Now, is this this parabola a U shape or is it a mountain shape? It's a U shape because there's no negative in front. And therefore I can go over 1 and up 1, over 1 and up 1, over 2 and up 4. There we go. And over 3 and up 9. So that'll be like right there. There's my parabola roughly. Okay. Is the vertex a maximum? Should be easy for you. How about equation in general form? Generally, you just multiply the thing out to get general form. But don't do the dumb way, x squared and 6 squared. That does not work. You have to have x plus 6 twice. And then a minus 1. So when you multiply it out, make sure you do it that way. And the y-intercept is just where you stick in x equals 0. All right, this one should be a piece of cake for you, I hope. All right, next, move on to a different page here. And this one, number 5, I want you to do that one also. Because it's already in general form. No, wait, I didn't have people do this one. You know why? Because it's so easy. All I have to do is factor it. And then you're pretty much done, except for the vertex. So after it's factored, you guys are so good at factoring because you just finished that factoring test. I bet this should be no big deal. How do you multiply to 24 and add to 10? 6 and 4 adds to 10, yes. So plus 6 plus 4. 6 times 4 is 24. There we go, good. So then what does that tell me? Negative 6 and negative 4 are the what's? Roots, x-intercepts, zeros. Yes. And since this is a U shape because there's no negative in front, I can tell the vertex must be right there, can't you? All right, anyway, I decided not to have people have to do number 5. So, but we definitely need to do this kind. So I'm assigning number 5 down here because I'm going to do some of it with you. But then you're going to have to do number 6 at home alone because it's got a stretch factor. Let me show you something. Do you remember how this thing goes over 1 and up 1, and therefore I can tell there's no stretch factor on it? If you look at this one, can you tell it's not over 1 and up 1? And therefore, there's a stretch factor. It's not too tough. You just got to figure out how much further up did it go than it was supposed to, and then use that for your stretch factor. All right, but back to this spot right here is at negative 1, comma 1, 2, 3, 4. Negative 1, negative 4. That's the vertex. Negative 1, comma negative 4. And then vertex form then is this, except you slap in the negative 1 and make it positive 1, negative 4. There's vertex form for that one. Since there's no stretch, I don't have to put anything up here. Since there's no flip, I don't have to put anything up in front. So that's it. Factored form, you could either multiply this all the way out and then factor it, or do you get how since it goes through 1 and negative 3, that tells you the factors? Going through 1, it's going through negative 3. So factored form, you just go, oh, it's going through 1, x minus 1. Going through negative 3, x plus 3. Okay, the x-intercepts are where, what? Y equals 0, so you could stick a y equals 0 in here and solve it. Or you could just look on the graph and see where it hits the x. X-intercepts are easy to see if you have a graph. That's an x-intercept, so is that. All right, so enough on that one. Now, 6 is the one that's going to be like that, except you need to do it. Vertex form, oh, there's a vertex. Shouldn't be too tough if you copy the same standard, same type as we just did over there. These are just your basic problems. There's no higher level thinking here. This is kind of more skill-based stuff. All right. So I'm going to clear this, move further into the worksheet. Okay, this whole next section is all about factoring, and since we just got done with factoring, it should be easy for you. Like, look at number 9. Look at number 9, what goes into everything? 2 does. So you just factor 2 out to the front, and then you factor it again, and you find your roots or zeros. Really easy from that. So this is going to feel like, whoo, that's so easy on the factoring, because we just finished that factoring test. So I don't need you to do any of those because we just got done with that. All right, so that's enough on that worksheet. Now, that was Unit 4.1, Quadratics A. Now we're going to go to Quadratics B. And that's it, the review worksheet right there. Do you remember half and square? He remembers you. All right, so you move the 12 over. Remember how to do half and square? I'll do this first one with you. It is a sign since I'm doing it. All right, so you do half of the negative 8 is negative 4 squared. Half n squared, right? So what's half a negative 8? Negative 4. Half n squared, negative 4 squared is what? 16. Plus 16 means I have to also have minus 16. And then this part will factor. And this part is the number that's outside the parentheses. So y equals something squared, and it's perfect. This is the same as the other one. So x minus something, hopefully you know what. And then this part right here, negative 16 plus 12 is negative 4. There. As soon as you know that number from factoring that, you'll be able to have vertex form. And then you'll know the vertex because it's just sitting right there. The opposite of this number and that number. Domain, if I had a picture, I can just make a picture. It's not too hard to do domain if you know you're starting down here as your vertex and it kind of looks like this, then the domain's easy. This way, domain has no limits. It keeps going forever. That's called the domain. This way is the range. It goes down to there, wherever that spot is, and it keeps going up forever. All right. I'm going to have you do A because I already helped you do a lot of it. Now we're going to scroll down to, what else did I have last hour do? Yes. C. C as in cantilever. And what's one of my favorite things? If you can factor it, you should. Just do it. That's the Nike theme. Something different than that. If you can factor it, you should. So I can factor those first two numbers. And it really bothers people sometimes that you don't have to factor all three. It's okay to leave the plus 19 over there. We're just factoring the first part here. 2 comes out, and we have x squared minus 12. No, got to factor the 2 out of that. So x squared minus 6x. Now is when you do half and square. If you would have done it earlier on the 12, it would have messed things all up. The number would have been too big. So now we got to cut down to 6. Now we do half and square. Half the negative 6 is negative 3. And then you square that. What's that? 9. If I put a plus 9 here, do you get I need something to balance it out on the dark side of the force? We'll have a negative 9 there. And then who can remember the most commonly forgotten thing? Yes? Yep. Because this one's going to be an 18 because of that 2. You have to double this one also. Whatever's up here has to also go there. Once you're done with all of that, that'll be your second one on this page that I want you to do. If you make a little sketch of it, once you know what the vertex form is, you'll know what the vertex is, and you'll know, oh, the vertex is like here. I can just make a little U shape because it doesn't have a negative in front, so you'll be quickly able to do the domain and range once you have a little sketch of it. All right, now, I need to move on. So much to learn, so little time. Okay, we're going to go, that's the second one in Quadratics. Now I got to find the third worksheet in Quadratics. It's called Applications, I think. I guess they just call it Applied Quadratics. That's right. Applied Quadratics. Find that one if you haven't already. pause for a second while we all get on the right page here. Okay, so on this one, this is applied quadratics. The applied quadratics means the calculators would definitely be allowed, and I've encouraged you before to get them out, so pretty much everybody has one on their desk at this point. I strongly encourage you to follow with this. If you need, I got one more up here if there wasn't enough calculators before. Got one? Okay. All right. So I would ask that on the first few, we won't need a calculator, but we'll need them in a minute. Do you remember how this equation has the velocity built right into it? Is it the first number, the middle number, or the last number? Middle. Okay, so on number 1, what's the velocity? 17.4. Go ahead and write that in. On number 2, what's the initial height, the starting height for that thing? 112. It's the last number, okay? And please write the equation then for something that starts at 8.24 meters and then has an initial velocity of 18 meters. You might ask, do you always use negative 4.9 in the front? Yes, you do, because you're on planet Earth, and that has to do with gravity, and it's using meters. Now, granted, you can actually do it in feet, but we kept ours simpler by always using meters, and that way you don't have to interchange two different numbers for the first number. You can just always use negative 4.9. All right, what did you get for that equation, NO? Did you end with plus 8.24? Okay, good. All right, there we go. Now, if you wanted to find the highest spot on that, you would type it into the calculator and then go second calculate what? Maximum. If you wanted to find when the ball hit the ground, what that looks like is this. What's that called on a parabola when the parabola would be hitting the ground right there? What's that called? The zeros, the roots, okay? And on your calculator, you go second calculate. Everybody hit second calculate. It's up by Trace. Second calculate, and do you see the option for that? Second calculate what? 0, okay? And the last one is, let's say I ask you for where is it at time 2? Well, at 2 seconds, let's say that 2 seconds is right there. That's second calculate a value of x equals 2. And you type in, it'll go second calculate value. It says x equals, question mark, with a little blank there. And then you type in 2. All right, knowing that, let's now do one more question. This is actually part of your homework here, is to get to problem number 6. Number 6. Suppose the baseball is thrown straight up with an initial velocity of 19.8. Oh, I know how to write that in the equation. Do you? Okay. Miss S, how does the equation always start? Yep, negative 4.9. I'm going to use x, but we could have used t. And then we have the velocity, Mr. W, in the front row. 19.8 what? X, good. And then the last part, Mr. W. Plus 1.5, excellent. And now, if I need the time at the maximum height, as soon as they said maximum, they had me. All I had to do is go, oh, second calculate maximum. Everybody do that. If your calculator is giving you issues, please start by checking with the person. Rows 1 and 2, you guys compare. Rows 3 and 4, rows 5 and 6. Compare with the person across from you and see if you get the same thing for the maximum height. And be careful, 2 numbers come up. One of them's time, and then one of them's the actual height at that time. So make sure you write down the right one. I'm going to pause while you give that a try. All right, so we're back, and right now, hopefully, you have typed in that equation. You hit second calculate maximum, and then it asks you 3 questions. 3 questions. It says left boundary, right boundary, and guess. And so the little black spider appears on your graph, and you go set. You bring it up to be just to the left of the top. Hit enter. to the right of the top, hit enter, get right on top and hit enter, and then what did it say? Well, it probably gave you a point. What, comma, what? Just tell me the whole point. 2, what was it again? 2 point what? 02, and then what's the other number? 21.5. Now, one of those is your answer. Think about it. Is it 2 gallons that yielded 21.5 flies in it? No, this doesn't make any sense. Well, what was it? 2 whats? 2 seconds went with what? 21.5 meters. So when they give you those two numbers, they're giving you a time and they're giving you a height. At 2 seconds, it was that high. So when they wanted the time, that was the time. Time is always the x's, so it'd be the first point of the, or first coordinate of the point. Okay, moving on. To be able to understand this well, I want to assign you one to do of these. I'd like you to go to number 11. Everybody please look at number 11. And on number 11, it's a soccer ball kicked across the field. First of all, you can write an equation for it. And then it says time when it hits the ground. Oh, when it hits the ground is right there. And that's called the what spot? 0, the x-intercept, the solution, the root, any of those. But the calculator is going to go second calculate the 0. Okay, and then the last thing is, how do I do this 8 meters off the ground thing? Nope. That would give you, if you typed in an 8, it would give you at 8 seconds. No, it's different. You graph a line. Good. The what line? Line at what equals what? Y equals 8. If you type in another y equals equation, it'll put in a line at y equals 8, and then it'll touch, like, let's say here. That means that's when the soccer ball was 8 meters off the field. Could it be possible, think about this now, would it make sense that it hits it twice? You're kicking a ball up in the air, it's going to go past 8 meters once on the way up, and then once again on the way down. So you go second calculate intersect to that kind. That's probably the hardest thing for today. You have 2 equations to put in there. Let's see where second calculate intersect happens. All right, so I'm going to clear this up. And so for today, we only have that. I do want to squeeze in one more thing just so I don't forget about it. You had circles, and I am going to show you a circle problem. If we had on circles a circle that had been moved off of the origin where they usually start, and it moved over 1, 2, 3, 4 spots over was where the center was, and let's say it's up 3, then that's at 4, 3. And let's say that it has a radius of 2. Can you write the equation for that? That's going to be on the ACT test too. Do you remember this? If you don't, let's practice it right now. Okay, so these have x squared plus y squared equals the radius squared. What is our radius? 2. So the end of the equation is 2 squared. So of course you could either put 2 squared or you could put 4. Then it's been moved to the right. So that means this number has to signify right. And how far to the right did we move? 4 spots. So how do you do right 4? Minus 4. And the last thing is it's been moved up 3 spots from normal. So plus 3 is the most common mistake. Why isn't it plus 3? It's inside, so you can't trust it. So it's opposite of what you'd think. So it's minus 3. There we go. Is this bringing back circles? I'm going to give you another one like it and see if you really get it. What if I had this? First, what is its radius? 4. Because the radius is over here, and it's the radius squared is 16, therefore the radius must have been 4. Okay, so that 4 squared could be there too. If I wrote it this way, it would have been just a little too easy to say the radius must have been 4. Okay, then how far did it move to the right and stuff such that what's the center of this circle? It starts at 0, 0, and then it moved to where? 5, 2. You got it. 5 to the right and up 2, even though that seems like down 2. Question? Yes, sir? The y-intercept is that rule we said a million times. The y-intercept is where? Still works for this. Yep. X equals 0. So put in a 0 for that. And then you get negative 5 squared. Then you have to subtract. And actually, I think, if I remember correctly, where I graphed this one doesn't touch the y. It's kind of a weird answer then. So what's the y-intercept when it doesn't touch the y-intercept? The answer will come out to impossible, as in you can't solve it, as in there is no answer. Okay? Because again, this circle, let me see if I actually was right about that. So if I go 5 to the right, and I have a radius of 4, do you get it won't be able to touch? So here's my center. And if I have a radius of 4, it comes back 4 spots, but it doesn't touch the y. It could touch the x, though. And the x-intercept is where y equals 0. So you could plug in a 0, and you could get answers for that. Okay. So that's circles, and that officially is all we have time for. I did show you problems I wanted you to do. You got to admit, I didn't give you too many. That means you got to do your part and get them done. Some of you guys haven't been doing that. I want to see good scores at the end for your own good. Get this done. Okay, that's all I have for you for today, unless there's any last questions. Okay,